And now we are going to have Patrik, who's VP Systems Architecture at Netnumber. And Patrik's going to talk to us about intergenerational 5G solutions and more than just cloud native. Thank you.
Hello, everyone, and thank you for the opportunity to take part in this event. My name is Patrik Rokyta. I am the Vice President of System Architecture at Netnumber and happy to share my thoughts with you on intergenerational 5G solutions. My presentation will take you on a journey showing how network elements of different 3GPP core network generations are deployed in physical, virtual, and cloud environments, and how data-centric intergenerational platforms can help in reducing the deployment complexity and in making the usage of the infrastructure resources more efficient. After the benefits of the infrastructure agnostic solutions are outlined and well understood, I will elaborate on the benefits coming from the unified operations, lifecycle management, security, and other areas. So let's start. Some or many of us have a long-lasting experience with the deployment of the network elements in 2G, 3G, 4G, IMS, and now 5G core networks. We know SS7-based network elements like SDP and HLR. We know diameter-based network elements like DRA, HSS, and PCRF. We know SIP-based elements like CSCF and TAS. And we know all the 5G core network functions that utilize the HTTP2 protocol. What has not changed is that a 3GPP core network of the new generation needs to interwork with the existing and older generations of the 3GPP core networks. 4G has to interwork with 2G and 3G, and 5G has to interwork with 4G, mainly due to a spotty 5G coverage and the lack of 5G roaming we may observe in the initial 5G deployments. With every new generation of the 3GPP core network, there was also seen the evolution of the underlying infrastructure technology. In 4G and IMS, the network elements run inside of virtual machines utilizing virtualized compute, network, and storage resources. For 5G, the preferred deployment model is utilizing the cloud-native infrastructure, providing for the management and orchestration of containerized workloads. The benefits of cloud-native infrastructure are well known and clearly understood. So today, 5G is the driver for the cloud-native infrastructure that will evolve to become the dominant one. But a 5G solution involves also the legacy network elements in the interactions defined for the 5G system. If such network elements need to be deployed together with the 5G core network elements, then the expectation will be running them on the same infrastructure type as used for the 5G network elements. Maintaining two different infrastructure types, one for the 5G network elements and one for the legacy network elements, is what I refer to as the deployment model bias that not only causes an increase of the operational complexity and cost, it also makes the usage of the infrastructure resources highly inefficient. And as for any other bias, also here, the optimal value of the deployment model bias is 0. Let's advance the slides. So we can continue hiding the different deployment silos under the management platform, or we may, and this is what Netnumber, the company I work for, is doing, use a platform that allows the network elements to run on the infrastructure of operator's choice. Such platform makes the network functions agnostic to the infrastructure type. I call it the zero bias deployment model. So let me tell you a story. 8 years ago, the rise of the virtualization technology has disrupted the product lifecycle of the SS7-based network elements. The SDP products of many suppliers have hit the end-of-life mark. Transforming the SDP and every other legacy product built of proprietary hardware and operating system to a virtualized network functions was considered as not profitable by many suppliers. But the SS7 network did stay, and with it also a group of vendors that have managed the technology transformation. The transformation of each product individually needs a rock-solid business case that copes with the nightmare of a continuously decreasing traffic volume predicted for the product in question. This is where telecommunication platform can help. Telecommunication platforms abstract the deployment technology from the business logic that is implemented in software. I have seen it with my own eyes, how easily a product implemented in software that runs on a Linux-based telecommunication platform can be deployed as a virtual machine running on a hypervisor. I have also heard all the arguments about the TDM links making such technology transformation impossible. But guess what? In the end, there are STPs running as virtualized network functions in data centers that concentrate all the IP-based traffic generated by the data link converters at the TDM outposts. The operators can easily scale the virtualized resources allocated to the STP virtual network functions and so cope even with the rather unexpected increase of the SS7 traffic due to the end of the roaming surcharges among the countries of the European Union. So what a win-win situation for the operators, the vendors, and of course for the people who travel periodically within the EU. And the story goes on. 4 years ago, the attacks over the networks of mobile phone subscribers have become more and more frequent. IMSI and MSISDN identities were harvested, the location of the mobile subscribers faked, password resets utilizing text sent over the SS7 network were intercepted, accounts hijacked, and people's reputation in the social networks damaged. The operators had to create special task force teams and introduce signaling firewalls in their networks. But this time, no one was really interested in a signaling firewall that utilizes vendors' proprietary hardware and operating system. As any other virtualized network element at that time, also the signaling firewall had to be a virtualized network function supporting both the SS7 and the diameter protocols and had to detect and stop even cross-domain attacks. The mapping between the signaling protocol and the infrastructure type has vanished. The problem was an intergenerational one, and so the solution had to be. Today, where almost everybody is convinced of the benefits of the cloud-native infrastructure, we cannot expect that such superior infrastructure will be out there just for 5G. We clearly see the demand for the legacy network elements to shift into cloud too. Frankly, the first deployments utilizing the cloud-native infrastructure will comprise many of the network elements from the 2G, 3G, 4G, and IMS networks. Cloud-native is not just 5G, and also 5G will need an intergenerational telecommunication platform. Let's move to the next slide. The key message so far is, the solutions and the products that we build shall be infrastructure agnostic. You can hardly explain to an operator that an intergenerational solution consisting of the network elements from different 3GPP core networks, and let's assume 4G and 5G for the sake of simplicity, also need two different infrastructure types. Intergenerational telecommunication platforms help in this task. So what I'm trying to say when promoting intergenerational telecommunication platforms is, be my guest, select the infrastructure you want. And believe me, I have seen 5G RFPs asking both the virtual and cloud infrastructures and even COTS hardware. So once we understand how the intergenerational solutions benefit from the intergenerational telecommunication platforms, we will also start to see the benefits in the other areas, such as the lifecycle management. Everybody understands that automation is a key element in building and operating networks in an economic way. But even after years spent with virtualized deployments, we are still struggling to see it with virtual network functions. This is now completely changing with the introduction of cloud-native products. Cloud-native products are composed of a set of containers that are managed and orchestrated by the container infrastructure management system like Kubernetes. A variety of tools exist today around Kubernetes and the container technology, delivering repositories, package management frameworks, databases, service meshes, monitoring, telemetry, security, and all kinds of other solutions that are utilized by highly scalable, containerized workloads, including the intergenerational telecommunication platforms. With virtual network functions, we have seen deployment artifacts with the file sizes in the range of gigabytes. The maintenance tasks that deal with such objects must be precisely planned and executed based on mobs, and any rollback within the same maintenance window can become a challenge. Such situations become rare with cloud-native products. Containers are lightweight, and the lifecycle management tasks can be applied to them in real time. With these well-known and explicitly defined tasks that involve, for example, CI/CD, can be fully automated. Blue-green and canary deployments can be rolled out, switched, and rolled back so easy. And these are just examples. In an orchestrated container-based environment, control loops periodically utilize the health and performance KPIs in state projection and automatically adjust the system without any manual administrative action needed. Many operational tasks such as scaling and healing at a container level do not even need an exposure to the operator. So again, why such a superior infrastructure with so many benefits should be out there just for 5G? And talking about the benefits, let's elaborate on a few of them in conjunction with intergenerational telecommunication platforms and 5G solutions. What should be clear to everybody by now, such telecommunication platform needs to be data-centric and cloud-native. Let's advance the slides. An intergenerational solution including 5G consists of multiple generations of network functions that coexist using a non-siloed resource pool and shared data. So let me outline a few aspects that need decisive actions to be taken. Important is the utilization of global data in the execution of the business logic and in routing decisions. Examples of such data include, but are not limited to, the number portability data, override services registry, access control lists, security, and network topology data. Efficient and cost-effective routing, as well as a superior security and fraud prevention, is often a result of utilizing global data across domains and regions. Equally important is the harmonization of the provisioning and the access to the subscriber data across 4G and 5G for data consistency and operational effectiveness. Data analytics and signaling security solutions implementing intelligent algorithms that combine machine learning capabilities with the subscriber and transaction-based data help to protect the subscribers from malicious callers, prevent attacks, and detect fraud, regardless of the network type and signaling protocol. By utilizing low latency and high throughput data pipelines, the intergenerational telecommunication platform can exchange data across sites and domains within milliseconds and help the applications to detect and prevent fraud in real time. As already outlined, less time and money is spent for the deployment and operation of network services when using automation. Service modification, upgrades, and rollbacks are performed at less risk and at zero service downtime. The deployment state is defined in a declarative way, rather than as the expected result of a sequence of configuration tasks or commands. Leveraging on the benefits of an intergenerational telecommunication platform, automated operations can be applied equally to the 5G network functions, as well to any other network functions needed in the interworking scenarios defined between the 5G system and other networks. Intergenerational solutions need to be cloud native and therefore portable between different infrastructure types, including the infrastructures of the public cloud providers. With this, operators can migrate selected components of the 5G networks onto the infrastructures of the public cloud providers and save money for getting billed only for the used cloud computing resources available on demand. Like the network services, also the infrastructure is defined through machine-readable definition files utilized in a process referred to as the infrastructure as code. In the end, such process can manage even multiple on-prem and external infrastructure instances that need a federated monitoring layer for observability and closed loops across the entire network service deployment. As we know, the 5G system has introduced a service-based architecture with a built-in service discovery and service access authorization. The service-based architecture has been recently adopted by the 3GPP management system, responsible for the management of the 5G network slices and network/subnets, for the provisioning of the network functions, for fault supervision, performance assurance, and other management tasks. With the help of an intergenerational telecommunication platform, the operator can migrate from the legacy FCAP services and protocols to the HTTP-based management services, utilizing the 5G network resource model, JSON objects, and the Open API specification. New services and service instances can be spawned based on HTTP requests with or without the involvement of the NFV management and orchestration components. Over to the next slide and to the question, who is Netnumber? As any other vendor, we have the responsibility for the implementation, delivery, and support of business and mission-critical telecommunication solutions and products. They allow the people around the globe to connect and to communicate. They can save lives. The Netnumber Titanium intergenerational platform delivers on the promises outlined in this presentation. Being able to provide a combination of the deployment flexibility and sophisticated intergenerational solutions in the signaling, security, routing, and global data area is the reason why Netnumber is known and valued by the industry. With this, we have reached the end of my presentation. I hope you had a good time.